Have you ever wondered what keeps the world's tallest skyscrapers standing tall and sturdy? It's all about cement, a material so common, yet so crucial. But what's the story behind this unsung hero of construction? Who transformed it from a natural material to the backbone of our cities? Stay with us until the end and discover not just the fascinating journey of cement, but also some surprising types of cement you might never have heard of. The journey of cement is as old as civilization itself, dating back to ancient times. But it was not until the 18th century that we witnessed a groundbreaking revolution in its production. The credit for this transformation largely goes to an often unsung hero of material science, Joseph Aston, an English bricklayer turned builder. In 1824, he patented what we now know as Portland cement, named after the Portland stone it resembled. This was a game changer. Why? Aston's method involved the superheating of a precise mixture of limestone and clay, a process that significantly enhanced the strength and durability of the product. This marked the beginning of the modern era of cement, setting the stage for the massive, awe-inspiring structures we see today. So the next time you walk past a building, bridge, or tunnel, remember the centuries of innovation and evolution that have gone into that seemingly mundane gray substance, holding it all together. Delving into the heart of cement production reveals a fascinating and complex process, a symphony of engineering and chemistry. It all starts with the raw materials, primarily limestone and clay, which are extracted from quarries. These natural ingredients are the foundation of cement, but how they transform into the final product is a process steeped in science. The first step is crushing and grinding the raw materials into a fine powder. This meticulous grinding is crucial, as it determines the reactive surface area of the raw materials, influencing the efficiency of the next steps. Next comes the blending stage, where limestone, clay, and other additives are mixed to create a homogeneous blend. The composition is critical here. Slight variations can lead to different types of cement, each with unique properties and uses. Now we enter the heart of the process, the kiln. This is where the magic happens. The raw material mix, now called raw meal, is heated to about 1450 degrees Celsius in a rotary kiln. This extreme heat triggers a series of chemical reactions, a process known as calcination, where calcium oxide and other compounds are formed. As the material moves through the kiln, it undergoes various reactions, eventually emerging as clinker, marble-sized gray balls, the precursor to cement. The clinker is then cooled and ground once more, this time mixed with a small amount of gypsum. The gypsum acts as a regulator, preventing the cement from setting too quickly when water is added. Finally, after this grinding process, what emerges is the fine gray powder we recognize as cement, ready to be packaged and shipped to construction sites worldwide. This entire process, from quarry to bag, is a delicate balance of chemistry, engineering, and precision, ensuring that the final product is not just consistent in quality, but also capable of holding our modern world together. Cement might seem like a one-size-fits-all kind of material, but it's far more diverse than most of us realize. The variation in types of cement is essential for different construction needs, each type tailored to meet specific requirements of strength, setting time, and chemical resistance. One of the most common types is ordinary Portland cement, OPC, the all-rounder in the cement world. Used in a wide range of buildings and structures, OPC is prized for its versatility and strength. But when different properties are needed, other types of cement come into play. For instance, there's white cement, used primarily for its aesthetic appeal in architectural designs. It offers a cleaner, brighter finish compared to the typical gray color of standard cement. Then there's rapid hardening cement, a time saver on construction sites, setting much quicker than the standard type. This is particularly useful in projects that require a fast turnaround. We also have low-heat cement, specially formulated to generate less heat during the setting process, reducing the risk of thermal cracking in large concrete structures. And not to forget, sulfate-resisting cement is designed to withstand harsh chemical environments, making it ideal for use in foundations where soil has high sulfate content. Each type of cement is a result of careful alteration in the composition and manufacturing process, tailored to meet specific construction challenges. It's a testament to the versatility and adaptability of cement as a material, capable of evolving to meet the dynamic needs of construction across the globe. Cement's contribution to modern construction is immeasurable. It's the backbone of the buildings we live and work in, the bridges we cross, and the roads we travel. Its role extends far beyond just being a binding agent. It's the foundation of modern infrastructure. In skyscraper construction, cement's strength and versatility make it irreplaceable. It supports the immense weight of these towering structures while withstanding natural elements like wind and earthquakes. The sheer height and elegance of modern skyscrapers would be unattainable without the advances in cement technology. But it's not just about towering giants. Cement is integral in residential construction, providing durability and longevity to homes. It's used in foundations, floors, walls, and even decorative elements, offering a balance of strength and flexibility that is essential in housing. Furthermore, in the realm of public infrastructure, cement is a silent hero. From the vast networks of highways and bridges that connect cities to the dams and ports that power our industries, cement is everywhere. Its ability to adapt to different construction needs, be it underwater use in ports or high-strength requirements in dams, showcases its versatility. As we've journeyed through the world of cement, it's clear that this ubiquitous material is far more than just a component of construction. From its rich history and the groundbreaking invention by Joseph Aspdin to the diverse types of cement tailored for specific uses, cement is a testament to human ingenuity and innovation. We've seen how cement is intricately crafted through a complex process, blending art and science to produce a material that's the foundation of our modern infrastructure. The skyscrapers that pierce the sky, the bridges that span vast waters, and the homes that provide shelter and comfort, all stand testament to cement's vital role in construction. But beyond its structural importance, we've also explored the environmental impacts of cement production. The industry's efforts to mitigate these effects through sustainable practices and innovative technologies are paving the way for a greener future in construction. As we conclude, let's reflect on the significance of this gray powder that quietly holds our world together. Cement is not just about building structures, it's about building the future. A future that balances human needs with environmental stewardship. Thank you for joining us on this fascinating exploration of cement. Don't forget to like, share, and subscribe for more insightful content.